This video will focus on the discussion of addition of signed binary numbers. And when we say signed binary numbers, our numbers may contain positive or negative binary. But the question is, how can we determine if a given binary number is a positive or negative? And we have already discussed that on our previous videos. But before moving on the proper lesson of addition of signed binary numbers, let's have a sort of review on how can we identify if a given binary number is a positive or negative. So let's take this example. Let's say we have, how can we check if this is a positive or negative? Remember in our previous video, we have this what we call the sign bit. And the sign bit is usually located at the most left side of our binary. So in this case, this is what we call the sign bit. Sign bit is the binary that contains the sign of a given binary number. If the sign bit contains 0, this means our binary is positive. If the sign bit contains 1, then it indicates that our binary is negative. So in this example, we have a 0 bit here for our sign bit. So this means that this number is positive. And if we are given this example, let's say we have 1001 0010. So just look at the most left side of the binary, which is what we call the sign bit. And in this example, the sign bit contains 1, and this indicates that this binary is a negative binary. Okay, so meaning, just look on the sign bit. If it contains 0, that is positive. If it contains 1, then that is negative. Okay, so let's move on. So let's take this example. Let's say we have this first problem. Number 1, 0, 1, 1, 0.11. And then 1, 1, 0, 1.11. All right. So looking on the sign bit of the first given, so we have a 0. So this shows that this is a positive number. For our second given, looking on the sign bit, which is this one, this shows that this given is a negative. Now let's try to identify the decimal form of the first given. So this is 6. This is 0.5 and 0.25. So therefore, this is 0.75. And then for the second given, we know that this is a negative number. So we need to apply 2's complement so that we'll be able to get the positive number of this. So let's write here 2's complement so that we will be able to get the positive version of this binary. So in applying 2's complement, the shortest way is to copy the first bit, the first occurrence of 1, and then followed by inverting the remaining bits. Okay, so there you go. So this shows that this number here is 2 because this is 1, 2, 4, 8, and we cancel those zeros because we have 0, 0, 0, and then we have to cancel those numbers. So what remains here is just 2. So meaning this is 2.25. So this shows that this is negative 2.25. All right. So let's erase this one. Okay, now let's add these numbers because our topic is addition of signed numbers. So we are adding positive 6.75 plus negative 2.25. So what is the result? So let's check. So 5, 5. So this is 0. 7 minus 2, this is 5. And then 6. plus negative 2. Basically, this will be a subtraction also. So this becomes positive 4. So we have now 4.5. Okay, so let's do the same thing here. So instead of doing subtraction, just like what we did here, what we will do, since we applied 2's complement on this, and basically this is already in the form of 2's complement because that is the representation of negative 2.25, 110.11. So let's add. So let's start. 1 plus 1, this is 0, carry 1. 1 plus 1 plus 1, this is 3, carry 1. Then we have to maintain the radix point. 1 plus 0 plus 1, this is 0, carry 1. 1 plus 1 plus 0, this is 0, carry 1. 1 plus 1 plus 1, and this is 1, carry 1. And then 1 plus 0 plus 1, this is 0, carry 1. Okay, carry 1. So we don't have any numbers on the left side. That is why we are going to drop just next with 0 the carry bit, which is 1. Because 1 plus 0 plus 1, that is 0, carry 1. And we don't have any numbers at the left side. So that is why we have to drop it just next to the 0. Okay? So now, let's observe our answer. So this is our answer. So remember that on our given, we have only 4 bits on the whole number part and 2 bits on the fractional part. Same with the second given. We have only 4 bits on the whole number part and 2 bits on the fractional part. So therefore, our answer should be on the same number of bits for our given. For fractional part, we have 2 bits, so it agrees to our given. For our whole number part, we have 4 bits, but our answer has what we call an overflow because we have 5 bits. So this part here is an overflow. Usually an overflow bit is discarded. So we have to discard this one. So meaning it will be removed because it will not fit on our memory register. Okay, so overflow is removed. So what is left now is just 0100.10. So if we are going to convert this into decimal, so this gives us 1248. The rest are all zeros, and what is left here is just the 4. So let's mark here 1, 2, 4, 8. So 8 has a 0, so let's cancel that out. 2 has 0, cancel. 1 has 0, cancel. So what will remain is just 4. So this shows that the whole number here is 4. And then for this part, this is 0.5. So what we have here is just 0.5. So this is now our answer, which is very equivalent to what we have on our decimal form, 4.5. So that's how we add positive binary to negative binary. So we will not do subtraction, instead we will do addition. Right, so let's have another example. So this time let's try having this number. Sample number 2. Let's say 0110.01 and then 1010.01. All right. So let's determine the decimal form of the first given. So this is 6.25. And then we have to add this to the decimal form of this second given. So now let's take a different approach on how we can determine the decimal form of this number. So what we will do is we will mark this with 1, 2, 4, 8. And we know that this is the sign bit. This number here is the sign bit. Okay? So therefore, this is sign bit. This means that this is a negative number. So that is why we are going to put negative on our number 8. So let's add. Okay? But before we add, we have to cancel those numbers having 0 binary. Okay, so let's add, and this is 25.25. So this is 0.25. All right, so let's continue adding. Negative 8, this one, plus positive 2, plus 0.25. Okay, so let's pad this with 0 so that we'll be able to identify which column belongs to a column. And let's pad this with 0 also. So let's add. So adding this becomes negative 6. Okay, so negative 6 on this part, we have already an answer for negative 6.00. This is negative plus 0.25. Okay, so on this part, we have to cancel this out. This becomes 5 and this becomes 1, but we have to borrow from here. So this becomes 9 and this becomes 10. So 10 minus 5, this becomes 5. Then 9 minus 2, this becomes 7. Point, just bring down 5. So this is negative 5. So this shows that 1010.01 is negative 5.75. Okay. So again, let's review what we did here. So let me erase this again. Okay, so we know that the sign bit of this second given is 1. So therefore, this is a negative number. And for us to check whether our answer is correct, if we were going to add these two binary, we have to transform each given into its decimal form. So for the first given, that is 6.25 in decimal. For the second given, that is negative 5.75. How is that we were able to know that 1010.01 is negative 5.75? Because what we did here is we subtracted this with 8, 4, 2, 1, and this is 0.25. So we canceled out those with zeros, just like the number 4, it has a 0 bit, and the number 1, it has also a 0 bit. Then, since this is the sign bit, so it means that our 8 here is negative 8. And then, we have to add those numbers with 1, and that is the negative 8 plus 2 plus 0.25. And that gives us an answer of negative 5.75, which is this one. Okay, so that's how we were able to get negative 5.75. All right, so let's continue. Let's now try adding these binary numbers. Okay, so let's start with this. 1 plus 1, that is 0, carry 1. And we drop 1 here, copy the radix point. 0 plus 0, that is 0. 1 plus 1, 0, carry 1. 1 plus 1 plus 0, 0, carry 1. 1 plus 0 plus 1, that is 0, carry 1. And then we have an excess here. We have an excess. So the excess is what? Is an overflow. So meaning we have to drop this off. Okay? Discard this value. So what remains here is just 0.10. So let's check if we have a correct answer. So for us to check, we have also to subtract 6.25 with negative 5.75. So let's do this. So this becomes 0. Okay, this becomes 5 because borrowing this one, this becomes 5 and this becomes 12. 12 minus 7, and that is 5. And then 5 minus 5, that is 0. So meaning this is 0, this is positive 0.50, which is equivalent to this one. So this is 50 because the value of 1 here is 1 half. And 1 divide 2, 1 half, no? 1 divide 2, that is 0.5. So that is why this one here is equal to this. Okay, so let's proceed to another example. So in our third example, let's take a different approach. Instead of having binary numbers as the given, we will have decimal numbers as given. So example number 3. So let's try here. The given are 53.25 plus negative 99.125. Okay, so just to make this column match to the other side of the column, let's pad this with 0. So let's try adding this. So this becomes 5, this becomes 7, and this becomes 8, and this becomes 5, and then this becomes 4. And the highest number is 99. So we have to copy the sign. So this is negative 45.875. So now what we will do is to take the binary form of each decimal given here. So let's start with this. So we know that this is a positive. So the positive form of this is 0, 0, 1, 1, 0, 1, 0, 1.010. And then we have to add this to this negative given. So how can we identify the negative binary form of this negative decimal? Okay, so first we have to write down the positive form of this. So the positive form of 99, so positive form, no? Positive form of 99, 1.25. So the positive form of this positive form is 0.011. So that is the positive form. For us to get the negative binary form of positive 99.125, we have to apply 2's complement to this binary. So to apply 2's complement, what we will do is to copy all the bits from the right side, and then we stop copying when we encounter the first one. The most right side is already 1, so that is why we stop copying from there. Let's just copy 1 here, and then invert the remaining bits. Invert, invert. This becomes 0, 0, 1, 1, 1, 0, 0, 1. So this is now the negative 99.125 in binary. Okay, this one here. So let's copy that at the top. 1, 0, 0, 1, 1, 1, 0, 0.111. There you go. And then let's add 0 plus 1, this is 1, 1 plus 1, this is 0, carry 1, and then 1 plus 0 plus 1, this is 0, carry 1. We maintain the radix point. 1 plus 1 plus 0, this is 0, carry 1, and then we drop 1 because all the bits here on this column are all zeros, so we just drop the 1 here. And then 1 plus 1, this is 0, carry 1, 0, carry 1, 1, 2, 3, we have 3, so that's why 1, carry 1. And then we have 2 ones here, so 0, carry 1 again, and then we have to write, just drop the 1, and then 1. There you go. So we have now this binary. Now let's check. Remember that the sign bit is 1. So this means that this is negative. Okay? So let's check if this binary form is really equal to negative 45.875. So for us to check, let's copy this number. Okay, let's copy this number around here. So 1, 1, 0, 1, 0, 0, 1, 0.001. Now let's add. We know that this is 1, this is 2, this is 4, this is 8, 16, and this is 32, this is 64, and this is 128. And this is the sign bit, so we have to add the negative there. Then we have to cancel all those zeros. So 32 is cancelled because 32 has a 0. 8 is also 0. 4 is also 0. 1 is also 0. And this one is 0.125. So we have to add all these numbers starting from negative 128. So let's write here negative 128 plus 64 plus 16 plus 2 and then plus 0.125. And let's pad this with zeros. 0, 0, 0, 0, 0, 0, up to the last whole number. Okay, then let's add. Now you can use your calculator to check if this is really equal to negative 45.875. But basically, if you will add this, all of these numbers, it will give you a result of this one, negative 45.875. So 128 plus negative 128 plus 64 plus 16 plus 2 plus 0.125, and that results to negative 45.875, which is equal to our answer in decimal. So I guess that ends this video. Thank you for listening, and I hope that you have learned something. See you in the next videos.